Assalamualaikum and good evening. I'm Kowi at Pentas. Today, we bring you a special field report by Semester 6 Civil Engineering student from UiTM Shah Alam under the course ECG563 Traffic Engineering. A road safety audit was conducted at the road section in front of Kolej Teratai bus stop with an active area with frequent vehicle and pedestrian movement. The aim of this audit is to identify safety issues on site, carry out suitable field studies such as traffic volume and spot speed studies, and suggest safety action based on the accepted guidelines. Let us go now to our reporter at the site, Nas.
Thank you, Kowi at Sri Pentas. So today we are here live to observe several safety audit procedures that will be conducted by Semester 6 Civil Engineering student. So today with me, AFIZUL, or better known Pijol. Hi Pijol.
Hi.
So what are you doing right now?
Right now I'm conducting a traffic volume study, which is a survey to measure the number and types of vehicles that passing through a particular road within a specific time of period.
Okay, so can I ask you what is actually a traffic volume and how the procedure is carried out?
Today we choose a straight road as our survey. Okay, before that what we need is mitigation counter, field data survey form and stopwatch. Okay, the procedure is quite straightforward. First we must select a clear observation view with a clear traffic flow, and we must conduct it during the peak hour. Today we decided to conduct during 1 hour with 5-minute intervals. We measure the number and type of vehicle that passing through this straight road by using the multi-tally counter according to the categories, and that's all.
Alright, okay, thank you for the information. So just now you just mentioned that the procedure is conducted on the straight road. How about the junction, like T-junction? Does the T-junction can also be conducted by using this method?
Yes, this method is not limited to the straight road. It's also applicable to the T-junction and intersignalized intersection. However, at junction, the procedure may be slightly more detailed because there are more different movement like left movement, right movement and through. And we also need the additional observer because to ensure the data is accurate and follow the GHANI standard.
Alright, okay. So thank you for the information about the traffic volume study. So thank you, Bijol. Thank you again. So okay, guys. That's all for the traffic volume study.
For the data analysis, the traffic volume was recorded for 1 hour from 8 AM to 9 AM. The total traffic volume recorded was 592 vehicles with 269 vehicles from direction 1 and 223 vehicles from direction 2. All vehicle counts were then converted into PCU based on JKR conversion factors for urban roads. After conversion, the traffic volume is 240.75 PCU per hour for direction 1 and 198.5 PCU per hour for direction 2, giving a total of 439.25 PCU per hour. Based on this result, graphs were created to show the traffic volume trend and the frequency of vehicle types, which indicate that direction 1 has higher traffic flow during the observation period.
So how about we continue with the next reporter, which is Eva, for the next part of study.
Thank you, Nas. So here right now with me is Adam. So Adam, as we can see right now behind us, they are doing something. So can you explain what actually they are doing?
Okay, right now we are conducting a spot speed study around this area.
Alright, interesting. So can you explain more about what is a spot speed study and how to conduct?
Okay, so a spot speed study is carried out to measure the vehicle speeds at a specific point on the road. We do not follow the vehicles, we just record their speed as they pass through this location. So for the procedure, first we choose the straight road section with good visibility and minimal disturbance such as bumper, traffic light and so on. And then we record the speed of each passing vehicle using radar gun and then take the data. So for the apparatus, we are using radar gun, and then we also use wheel meter to measure the distance and then take the data.
Alright, so if you don't mind, may I know from the result what will be done and related to the JKR standard, what we need to refer regarding to the spot speed study?
Okay, after collecting sufficient data, we analyze it to obtain the fifth, 50th and 85th percentile speeds. Since there is no speed limit signage in this area, the result can also refer to JKR guidelines, especially the 85th percentile speed, to recommend a suitable speed limit and improve overall road safety.
Alright, thank you, Adam. So that's all from me.
For this spot speed study, speed data must be collected at a location near bus stop Teratai under free flow traffic conditions in accordance with JKR guidelines. The data collection is carried out by recording vehicle speeds for a maximum period of 1 hour or until at least 100 vehicles are observed. Whichever is achieved first. The collected data is then arranged and analysed using percentile distribution, and the 85th percentile speed is determined as recommended by JKR to represent the prevailing traffic speed for road safety and traffic management assessment.
So back to the Nazzerah, who will cover the next part of study, which is related to the lighting. So stay tuned for tonight.
As you can see at this location, the lighting is very dim and poorly lit. This condition can lead to unwanted incident happening. Based on the camera footage that we got, we can clearly see that the accident easily occur. That's all from me. Nas, back to you at Sri Pentas.
Thank you to Nas and Eva for the field update. From what we have seen just now, several safety issues were observed at this location, including the traffic movement, vehicle speed, and lighting condition. To address the issue, several safety actions have been identified, such as maintaining existing facility and adding visual guidance to assist road users. However, lighting is not the only safety element given attention in this audit. Other road safety elements were also observed and assessed by the team. Let us now watch the next field report prepared by our team.
Based on the road safety audit, the first issue identified is vehicle speeding near the bus stop Teratai. Many drivers travel at high speed due to there is no clear warning signage even though the location is within the campus. Driver tends to bypass existing speed hump by driving along the road edge, reducing the effectiveness. To mitigate this issue, it is proposed to install proper warning and signage such as speed limit sign together with a road marking. The existing speed hump should be upgraded to full width speed table to prevent vehicle from avoiding it. This mitigation is referred to Arahan Teknik Jalan ATJ5/85 and Akta Pengangkutan Jalan 1987, which emphasize speed control and traffic calming in pedestrian area. The second issue involved poor vehicle alignment at junction, where vehicle cross into opposing lanes due to unclear road layout and marking. To address this, clear lane marking, aid lines and directional should be installed to guide vehicle movement, especially at intersection. This improvement help drivers maintain proper lane discipline and reduce conflict during turning movement. This mitigation is based on ATJ2/85 road marking by JKR, which outlines standard road marking requirement for safe junction operation.
The road is designed according to the JKR U3 standard, suitable for moderate traffic volume and low speed conditions, such as internal campus road. A lane width of 3.25 meters ensure a safe and comfortable movement of cars, buses and service vehicles. A paved shoulder of 1.5 to 2.5 meters provides space for emergency stopping and improve lateral clearance, helping to reduce run-off road accidents. Overall, this cross-section design balances safety, functionality and efficient lane use in accordance with JKR guidelines. The geometry layout of the road is designed in accordance with JKR U3 standards as outlined in Arahan Teknik Jalan 8/86. Since the road is straight, emphasis is placed on maintaining a clear lane alignment and providing adequate lane width and shoulders to ensure safe and comfortable vehicle movement. Vertical alignment is designed to provide sufficient stopping sight distance, allowing drivers enough time to react to obstacles, pedestrian or campus traffic. Shoulders of 1.5 to 2.5 meters provide space for emergency stopping and improve lateral clearance, enhancing overall safety. This measure based on JKR standard ensure the road is safe, visible and efficient for all campus users.
As a mitigation measure, traffic signals should be provided only where warranted and designed according to Arahan Teknik Jalan to ensure safe and efficient traffic management. The location, spacing and visibility of signal faces must be carefully planned to operate effectively for all road users. Adequate signal hardware with redundancy should be installed to maintain reliable operation. Pedestrian signal provision should be included, especially in built-up areas to ensure crossings. Proper signal timing and coordination will help manage traffic flow, reduce delays and minimize the risk of accident. The next mitigation measure is the use of visual aids, specifically a ghost island, which is designed following Arahan Teknik Jalan. However, at the study site, the existing ghost island is not clearly marked and lacks proper visibility, which may confuse drivers and reduce its effectiveness. A ghost island is a painted traffic island that helps separate traffic streams and guide vehicles into the correct lanes. This visual guidance improves driver awareness, especially when approaching junctions or turning areas. By complying with Arahan Teknik Jalan, the road markings and layout become more consistent, improving lane discipline and reducing the possibility of sudden or unsafe maneuver.
In terms of vulnerable road user infrastructure, specifically zebra crossing and road markings, side road markings are present. However, directional movement arrows are not provided. And although a bus stop exists, there are no dedicated bus stop road markings. In addition, no zebra crossing is installed at pedestrian crossing points near the student residential walkways. These deficiencies may cause confusion in vehicle movement and increase potential conflicts between vehicles, buses and students crossing the road. According to Arahan Teknik Jalan 2D/85, road marking and delineation, zebra crossing must be clearly marked using standard white transverse lines to indicate pedestrian priority, typically with width and length between 1.6 to 3.6 meters, and each stripe having a 0.6 meter width. Directional movement arrows and bus stop markings are also part of standard regulatory road marking under the same guideline. Therefore, it is recommended that zebra crossing, bus stop markings and directional road arrows be installed at strategic location within the residential area to improve pedestrian safety, traffic clarity and driver awareness. In terms of street lighting, although lighting poles are installed, several lights are not functioning and some are partially obstructed by trees, especially near pedestrian walkways and crossing areas. Inadequate lighting increases accident risk at night. Therefore, repairing faulty lights and trimming vegetation is recommended to ensure adequate illumination. Finally, cat eyes or raised pavement markers are not installed. As specified in Arahan Teknik Jalan 2D/85, installing cat eyes near pedestrian crossing, bus stops and along residential road will improve nighttime visibility and driver guidance.
During our observation, we found that trees are planted too close to the road with excessive branches extending towards the carriageway, which not only may pose a safety risk if branches fall onto the road and obstruct passing vehicles, but also significantly reduce the required clear distance and restrict the line of sight for drivers. This limitation can endanger road users, particularly motorcycles and vehicles traveling at high speeds, as it reduces reaction time and increase the likelihood of collision, especially in areas with limited lighting and adverse weather conditions. According to the Intermediate Guidelines to the Road Reserve Landscaping, Nota Teknik Jalan 1997, Section 4.3, adequate clear zone distance and proper line of sight must be maintained with tree branches at least 5 meters away from the road surface. Therefore, regular landscape maintenance is necessary to trim overhanging or low branches, restore proper clear distance, maintain clear visibility, and enhance overall road safety for all road users. During our observation, we found that the road surface condition is poor with uneven pavement, damaged areas, and potholes. This defect causes vehicles to avoid the damaged section, leading some drivers to move slightly into the opposite lane, which creates a dangerous situation and increases the risk of vehicle collision. This condition is especially hazardous for motorcyclists, as potholes can cause loss of control and increase accident risk while also damaging vehicle tires and suspension system. According to the standard specification for roadworks, Section 4, flexible pavement, particularly Section 4.12 on surface treatment, road surface should be constructed using suitable materials to ensure safety, durability, and riding comfort. To mitigate this issue, regular road maintenance should be carried out to prevent further deterioration. High-quality pavement materials should be used, and an effective drainage system should be provided to prevent water accumulation that can lead to pothole formation, thereby improving overall road safety and traffic performance.